Hello, my name is Eddie Vergara, and I'm a Xilinx Product Applications Engineer. Welcome to this video demonstration of the ISE Simulator software. In this video, we'll demonstrate how ISim, available in ISE Design Suite 12, can help you debug and verify the functionality of your design. This demo is divided into 6 different topics. We'll first provide a quick overview of the ISim software. We'll then demonstrate how easy it is to launch a simulation of your design using ISim. We'll take a close look at the new and enhanced ISim graphical user interface. We'll also go over some key features of ISim that allow you to effectively verify and debug your design. We'll point out different help and tutorial documentation available to learn more about ISim. And we'll finish the demonstration with ideas and suggestions on how you can start using ISim today. The ISE Simulator, or ISim for short, is an event-driven HDL simulator developed by Xilinx. It is included at no additional cost as a component of the ISE Design Suite. A light version is included as a component of the ISE Webpack offering. Note that all the features in the full version of ISim are available in ISim Lite. The only difference between the two offerings is that the ISim engine performance is derated when simulating designs with more than 50,000 lines of user code. ISim supports commonly used HDL standards like VHDL93 and Verilog 2001. It also supports mixed-mode simulations, allowing you to simulate designs that include both Verilog and VHDL code. It also leverages other standards, such as the Standard Delay Format, or SDF for short, used for back-annotating delays from a place and routed design in timing simulations. A Tickle interface for GUI and engine command scripting, and VCD or SAF standards for using simulation activity data for power estimation. ISim is tightly integrated with other components of the ISE Design Suite, allowing you to launch simulations of your designs within different design environments, like Project Navigator or the Platform Studio software. Also, ISim supports simulations of all designs using Xilinx devices, including designs that make use of hard IP such as the gigabit transceivers or memory controller blocks. Lastly, several new cutting-edge features in ISim 12 allows for increased productivity while debugging or verifying your design. We'll showcase some of these features shortly. ISim is included as a component of all ISE Design Suite and ISE Webpack offerings. This means no separate license file is needed to run ISim. ISim only checks out a license seed whenever the simulator engine is invoked and ran. The seed is checked back in once the engine has completed a simulation run. This means that the ISim GUI can remain open without requiring a seed, as long as the simulation is no longer an active process. If ISim is unable to find an available seed to run in full mode, ISim defaults to the light mode, allowing you to simulate your design as usual, albeit with derated performance if the design contains more than 50,000 lines of user code. ISim can be launched from different design environments. To launch a simulation from an ISE design, first add a test bench to your design. Test benches are HDL files that provide stimuli to your design, such as a toggling clock and input data streams. You can use features such as the new source wizard to have ISE build a test bench template in VHDL or Verilog, with basic test bench features such as a clock process or block. You can then use the language templates to add simulation constructs to your new test bench. And lastly, you can use Xilinx Application Note 199 to learn how to write effective HDL test benches. Once you have a test bench in place, make sure you have selected ISim as the preferred simulator tool. You can do so by reviewing the simulator selection under the design properties. An ISim icon demonstrates that ISim has been selected as the simulator tool of choice. To simulate, change the source view to behavioral simulation by clicking on the Simulation Radio button. Then, click once on the test bench. In the Processes pane, you'll see the Simulate Behavioral Model process is now available. Running this process starts the compilation process and launches the ISim GUI for verification of your design. New in ISim 12 is the ability to simulate within the Xilinx Platform Studio embedded design environment. To launch a simulation from XPS, first check that ISim is selected as the preferred simulator tool in the tool preferences. Next, make sure the project settings are set so that XPS provides a test bench template for this design. The template will include some basic test bench functions such as a running system clock and reset pulse, sufficient stimuli for a behavioral simulation. Once these checks are complete, ISim can be launched by clicking on the Launch HDL Simulator icon or the Launch HDL Simulator option under the Simulation menu. ISim can also be launched separately from design environments using batch scripts. This is particularly useful for command line users. ISim provides commands for completing each of the following simulation steps. First, the Verilog and VHDL compilers compile HDL into work libraries. Then, the ISim elaborator, called Fuse, elaborates all the precompiled code and produces a single simulator executable. This executable can then be used for execution of the simulation, either in batch mode or interactive mode, by making use of the -GUI switch. Detailed information on how to run these commands can be found in the help and tutorial documentation. Once the code has been compiled and the simulator executable is launched in interactive mode, you are presented with a new and enhanced ISim graphical user interface. The Instance and Process panel displays in a tree structure all the instantiated and elaborated entities or modules in your design. We can use the filter icons to show or hide different VHDL or Verilog types, such as VHDL packages or Verilog tasks. Furthermore, you can collapse or expand the tree hierarchy by clicking on each arrow. The Objects window shows the simulation objects associated with the selected instance or process. Similar to the Instance and Process panel, you can show or hide different simulation object types, such as wires, bidirectional signals, or constants. Using the Sync Time feature, values shown for the simulation objects can be set to update with the simulation runtime or synchronize with the Wave window cursor. The Wave window displays signals, buzzes, and their waveforms. Different wave objects can be added and configured in this window, such as dividers and groups. Last but not least is the console and tickle prompt, where you can both input simulator commands as well as review messages from the simulator.